Hi, good evening, everyone. Welcome to one of the sessions, one more sessions from 360 Digit MG, where we try to get people from industries with various experiences in different domains. And as part of the Industry Connect today, we have our special guest, Mr. Samir Paul,
Hi.
who is currently working as a senior manager at Oracle Corporation. He has overall 22 years of experience in various top-notch MNC companies, and he has worked in different verticals and domains. Mr. Samir Paul is also a PGP Max alumni from ISB, and he holds multiple certifications and multiple degrees, and that itself speaks about the zeal towards acquiring more knowledge on trending technologies and trying to constantly upskill in different areas. So our chief guest here, would like to share his views about various trending aspects in the marketing domain. So he will be speaking about marketing mix modeling and its applications with us today. I requested Mr. Samir to take over the stage, and I really appreciate and thank you so much, Mr. Samir, for connecting on Saturday evening on our request and sharing your knowledge with our audience. Thank you so much. I would request Samir to please share your screen and start your presentation.
Thank you very much, Sharath. Let me share my screen. So can you all see my screen?
Yes, Mr. Samir, yes.
Let me. Okay. So good evening, everyone. Thank you all for coming and joining this session this Saturday evening. As Sharath mentioned, I'll be talking about the machine learning and data science use cases in marketing. Mostly this session will be towards marketing mix modeling. However, I will touch upon the different use cases that we have. So if I go to this slide, you can see the different use cases that we have. It's not at all an exhaustive list, for sure. There are many more marketing use cases. But marketing, it all starts from where to play. Suppose we start a company today, or even if it is an existing business, the first question comes is where to play. And that's where the K-means clustering comes into picture. For technical people who knows data science and machine learning, this is a unsupervised learning. Basically, the Y variable is not there. So K-means clustering helps us in segregating the entire customer population into different segments. And then we do the profiling of those segments to understand what that segment is. And that insight helps the organizations to then decide on whether to enter that particular segment. And if they decide to get into that segment, then the other things comes into picture, what product to position, how to go about positioning that product, promotions, and other things. So that's customer segmentation. Typically in marketing, we do a lot of surveys to collect the pulse of the customer, pulse of the consumers. So a survey can contain many different attributes. And when we merge the different surveys, that number of attributes can be huge. But when we try to do the analysis, it is always good to have less number of variables. So the principle of parsimony is always better. So how do we make sense of so many variables into a smaller set of variables which are more meaningful? This is a kind of dimensionality reduction. If you have experience with data science, then you will connect this with dimensionality reduction. However, from business perspective, it's about identifying some latent dimensions out of all these different set of variables, so that from these latent dimensions, business can then take a decision. It has its application in the behavioral segmentation. It's more or less like related to principal component analysis, though there are some differences between PCA and factor analysis. As I said before, when we know that where to play, which segment to target, then comes the question of positioning the product, or even before positioning the product, we need to design the product, right? What product we can introduce for that particular segment. So in the field of marketing or in the field of product management, customer is the key. So we would like to understand from the customer what they prefer, and based on that we can design our product. So one statistical analysis tool called Conjoint Analysis is used here. So let's say an example that let's take car. Now, say interiors is one of the feature in the car, right? Now, whether the people would like premium interiors, or they would like normal interiors, whether they will like, if steering is another feature, whether they would like collapsible steering or they would like a simple automatic steering. So those are the kind of choices that we have to make. And any particular product can have many features. And out of those many features, there are multiple alternatives that can be given. But how a company will decide what feature value combination can be offered for a particular segment? One particular segment may like one feature value, the other segment may not like that. So conjoint analysis helps us arrive at that. It also helps us at the, in the pricing analytics too. Then CLV, this is the customer life cycle value. To understand this, say today a customer comes and purchases a product of say 1,000 rupees. Another customer comes and purchases a product say 300 rupees. Now, apparently it looks like that the customer which is paying more today, 1,000 rupees, is the more important customer, right? But we need to think about long term, that over a period of time, over a period of life cycle of that customer, what is the value that we will be getting from that customer. So there is a different technique for that we do CLV analysis, and based on that we can again do the different kind of promotions, different kind of strategies can be taken by the organization to cater to these long-term value customers. Another way of segmenting the customers is basically based on RFM technique, that is recency, frequency, and monetary. So it typically was used frequently in the retail domain. Recency means how recent was the purchase made by the customer, whether the customer purchased the last product 3 days back, 7 days back, a month back, or 6 months back. Frequency is how frequently customer visits the store, right? How frequently customer purchases from that store. And monetary is obviously what is the ticket size. So suppose he is purchasing, what is average ticket size for that particular customer. So combination of this RFM can also be used to segment the customer to get insights, and based on those insights, again, promotions, different kind of strategies can be taken. Then today's I'll be talking about this marketing mix modeling. So it's all about in marketing we try to do the promotions, advertisements, and all that through different channels. Prior to digital, we had those channels, we still have that, like radio, television, newspaper, banners. But with the advent of digital, you all know, right? A lot of ads are now coming into YouTube, Facebook, Instagram. So these social media channels are also there, apart from the traditional TV, newspaper. The question is, which channel is better? How much to, suppose I have 1 lakh rupees to spend on marketing. advertisement, how do I distribute these across the channels? How do I know which channel will contribute to more revenue? So that analysis, marketing mix modeling is all about. There is another thing that is multi-channel attribution. That's also a connected topic, but it's slightly different from marketing mix modeling. Then you all know the marketing response model. This is like whenever we do the campaign, how do we know that which set of customers will respond to our campaign favorably and who will not? If we can have that kind of insight before the execution of the campaign, and this is again based on the past data, obviously, if we can have that kind of insights, the organizations can then spend less money in the campaign and get more results out of it. So it's that's the marketing response model. And churn, you know very well, telecom, all the companies are trying to retain their customers. And even in the SaaS world today, in the cloud computing world, the applications, the customers are coming, customers only take the subscriptions. They don't buy the product, right? So it is all subscription based. So it is very important to keep the customer happy. If the customer is not happy, customer has not invested in hardware or software. So it's very easy for the customer to move to some other product or some other organization. So how do we manage this churn? How do we predict which customer is going to churn? And if we can predict correctly that these are the risky customers and these are the customers we are at risk of losing, we can proactively, organizations can proactively take some stand, devise some strategy to win them back. As I said, these are not at all an exhaustive list. There are many more things in marketing. One of the things that comes to my mind is A/B testing, which is very popular in the digital world. It's not actually about digital thing, A/B testing. It's about randomized experimentation. So it's an innovation mindset. And in the agile world today, how quickly we can do the rapid randomized experiments, learn from it, and then take the next steps. So that is A/B testing. So similarly, many more marketing use cases are there. Let me move to the next slide. So today's topic, right? Today, as I said, I will be talking about the marketing mix model. I'm sorry. Sharath, can you see this agenda slide? I'm not sure the way I'm.
Yes, I'm able to see the slide.
Slide, right? Okay, thank you. So first we'll talk about what is marketing mix model and why it is important. I just touched upon that. And then we will build a simple marketing mix model and we will be using Python. Doesn't matter whether we know Python or we don't know Python, or whether we use Python or R or any other GUI based tool. We'll be basically discussing the concepts here, that how do we create a simple model. Now, after creating this simple model, though I'm calling it as a simple model, it will throw a lot of insights that will help the business. So typically, the model will give us some technical details, but the business will not be able to understand that. How do we communicate our insights? I mean, the people who will be building the model, how do they communicate the insights that they are getting out of this model to business, so that business can make a decision and then they can devise the strategy, right? So we'll touch upon that. And then, as I said, this is a very simple model. We will then talk about improving the model. So there is a concept of at stock lag and carryover effect. And also we will be, we'll briefly discuss about that stock saturation effect also. So this is something which I was mentioning to you. MMM is the marketing mix model. It basically provides insights how the marketing spend across channels are driving the business objective, and ultimately how it is increasing the ROI. So it's all about like identifying the certain parts of the marketing activity or certain channels where the organizations need to focus. To give you an example, suppose suppose we are an organization and we have three channels: radio, banners, and television, and we can advertise in each of these channels. But where to focus, where to put more money, so that MMM or the marketing mix model will tell us. Now, marketing actually depends on four P's. People who are from marketing, they know this is the basic of marketing. That four P's are price, product, place, and promotion. So, what product to offer to the customer? What are its features? What price point are we offering? And where are we offering? I mean, place means the channel. Is it a retail store, or is it an online website? How are we, where customer can get our product, right? That's the place. And promotion is slightly different from advertising, though we can club that also. Apart from advertising, promotion also includes the discounts that the stores gives on a day-to-day basis, right? It's the different discounts, buy this, get this free, and different kind of promotions are there. So in reality, when we do the marketing mix model, all of these information can be incorporated into the model. Apart from that, we also cannot ignore the macro level factors. Right now, as you know, the interest rates, RBI is increasing the interest rates, right? CPI basically stands for Consumer Price Index, which actually tells about the inflation. Then there is gross domestic product, GDP. So these are macro factors which also impacts the sales or the revenue of the company. So those things also can be considered when doing a full-fledged marketing mix modeling. But in our model that we are going to talk today, we will be focusing mostly on the channel. How do we decide upon the channel spend to optimize the revenue? That's the discussion today, right? So this is the point. We shall examine today the impact of marketing spend on different channels, and namely TV, newspaper, and banner. Sorry, guys. And as I said that we will first build a model, we will interpret it technically, then we will think about how to communicate this to the customer in business language. And then we will see, like, since this is a very basic model, what are the scopes of improvement, and what are those concepts? So we'll look into that. So this is one screenshot that I have taken just to put the things into perspective. So I've taken this from this particular website, and here you can see from this basically tells about the marketing expenses from 2016 to 2022 US total media ad spending. So you can see there is digital, and then there is TV, print, again within the print, newspaper, magazines, radio. It gives us a perspective about how the marketing spends are happening. But a better representation is there in the next slide. If you can see this graph, this gray line, it is basically the percentage of the revenue, if I'm not wrong. Yeah. So it's a percentage of the revenue, and this is the marketing expense, right? Marketing expense is a percentage of revenue. So you can see a huge amount, 7.5% of the revenue of the company, or 6.9% of the revenue of the company is being spent on marketing expenses. So it is very important that this expenses that the organizations make are meaningful, and important thing is that it should yield result. And you can see here how from 18 to 21, how the marketing expenses were increased, right? It almost touched 13.2%. And here is the conundrum. John mentioned that half the money he spent on advertising is wasted. The trouble is, he doesn't know which half is that. So that's the conundrum, right? That's the problem any business, anybody is having today. And that's where analytics comes in. That's where all the machine learning comes in. And these models, what is the purpose of these models? The purpose of these models is to get some insight out of the data, from the past data, and help business to make some decisions which can get them better results. Typically, like if I have to predict what will be the sales, say next month, without any model, what is the situation? What can the business do? Definitely, the business people have insights. They have the domain knowledge. They know their business well, no doubt about that. But in terms of quantification, apart from the insights or the business knowledge they have about the business, technically, if they have to state what will be the next month's sales, the thing that comes to our head is, let's take average. We have the past data, let's take the average, right? So that's the benchmark, that without any model, we can predict, and that's like a bet that we take, and that's the average. Now, when we build any kind of model, whether it is a marketing mix model or any kind of prediction model or classification, basically let's stick to regression models, that is the prediction models, we have to come up with a percentage that is better than the average. Say average is 50%. So if we can build a model which is like a goodness of fit is say 70%, so that 20% increment is the business value that our model gives to the business, right? So that's the overall concept of analytical models. So we see this conundrum is there, and that's why we are doing the marketing mix model. So let's start with this, and I'm not sure about the people. I'll be using Python here, and as I said, it is a very basic thing. I will try to explain everything, and even if you do not understand the Python, I will try to convey what exactly I'm trying to do here. That is more important. So as you can see here, just a minute. So if you look at this table, it has TV, radio spend, banner spend, and then what was the sales, right? So I've just taken 3 figures here, okay? And this data is actually taken from a GitHub. I've mentioned it here. So what is sales? Sales is the dependent variable, right? Why it is dependent variable? Because ultimately sales is getting influenced by the advertisement towards TV, radio, and banner. So that's why we are calling this as dependent variable. And this is what is the final thing. But then this TV, radio, banner, this advertisement expenses, these are independent variables. So these are some terminology that is being used in data science and modeling. So just remember, sales is what is the Y variable or the dependent variable, and the TV, radio, and banner, these 3 attributes or these 3 marketing channels are the independent variable. Okay, so this is where some of the Python thing comes. This is nothing. We are just importing some libraries, Pandas is basically a library in Python to deal with the data frames. It's a super powerful library. And then as we will be doing the marketing mix model, we will be using linear regression, and we are importing that library. And time cross-validation. Cross-validation is one way of doing the validation for. So typically what we do in machine learning or data science is we whenever we get the past data, say 100 records, I'm just, for example, taking 100 records, then we may say that, okay, we will build the model on, say, 80 records. And once the model is ready, then you would like to test it or validate that model, then we use the remaining 20. So that's one way of doing it. There's another way, cross-validation, when the data set is small. I'm not getting into the cross-validation concept here because it takes a lot of time, but cross-validation is another mechanism. So what we are doing here, that data that I have shown you, that we are reading into a pandas data frame, right? This PD is, we mentioned it is pandas. So pd.read CSV, and then that CSV file, I'm reading it into a pandas data frame. And then once we read the data, I would like to see the data. Previously, I've shown you in the previous screen, the same data when it is loaded into the pandas data frame. I'm just showing the first 4 records from that data frame. So you can see that head means from the top of the data frame, show me the 4 records. And this TV radio banners, and then the sales. Then for modeling, as we discussed, that sales is my Y variable, and all other variables apart from sales, that is TV radio banners, they are my X variables. So I'm just constructing that Y and X. And then we can, we basically, what we do is any kind of modeling exercise or any kind of data driven exercise. We, even before we get to the model, the most important thing is to understand what is our data. It can tell a lot of insights. The data can reveal a lot of information. So we will do some of the basic exploratory data analysis with that. So we are trying to describe here, it gives us what is the mean, what is the standard deviation, and those kind of details for TV, radio, banners, and sales, right? So you can see the average or the mean for TV expenses is 2946. Accordingly, like 20 first quartile, second quartile, and all that kind of statistical analysis we can get here. Then what we need to do is, this is very, very important thing. The X variables are the independent variables, that is TV, banner, and radio. These variables should be independent for a model to give good results. They should be independent. That's the assumption. Now, sometimes what happens, they are not independent. They are related, correlated with each other. And if that happens, then the model equation that we will get, if that correlation exists between the independent variables, then the model equation will not be good. So whatever insights or we get out of that model will not be perfect. So we need to take care of that. And it's called multi-collinearity. So we try to, what we try to do, forget about this code here. What we try to understand here is there any correlation between TV and say banners? And if it is there, it is not good. Similarly, for all the variables, we need to check whether there is any kind of correlation. Now, correlation can be there. It can be 0.1. So correlation value of 0.9 will be very high. If you see the correlation between TV and TV is 1, right? That's the diagonal thing you can see here. But anything like, let me tell you here in this chart, forget about the code, 0.68, right? So this is little bit higher. Then it's higher, but it's okay because we are getting a correlation between the Y variable and TV. But then if you see this 0.0022, which is very small. So idea is basically here to figure out whether there is some kind of correlation between the independent variables, and if so, that's not good. Then how to, first of all, how do we detect it? One way is like generating this kind of heat map and using this CORR function that gives us the correlation. But it's not so, it gives an indication, but there is a better way of doing it, or rather I would not say better way. Many people prefer a different way of identifying the autocollinearity, and that's very simple. Let me go there first. I think I kept it in a different slide. So just focus here. There is something called VIF, variance inflation factor. Again, if you know code, you can look at this snippet, very simple code. But if you don't know the code, I'll explain you what is variance inflation factor. So variance inflation factor is, we take that Y variable out of our discussion for now. That is the sales. Let's take it out. Then we do the regression. Let's take TV, and we make TV the Y variable, and the banners and newspapers, those are X variable. So one of the X variable, we make it a Y variable, and we regress that new Y variable with the remaining X variables. And then we get the R square of it. What is R square? R square is nothing but the goodness of it. How good is the model? Typically anything, it's again depends on the industry, but anything above 70, 80% is good. So we then put this formula 1 divided by 1 minus R square, that gives us the VIF. So similarly, what I told you, that we kept the sales out of picture, we picked up TV and made it the Y variable and got the VIF of TV. Then what we do, we take the radio and we make that as a Y variable, regress that with all other independent variable. We get another VIF that is for this newspaper, right? So ultimately, that's the concept, okay? So all the independent variables you can see here, which are nothing but our channels, and then we get the VIFs. See, if the VIF is greater than 5, again, a different literature, different text has different preferences, but most of the places I have seen greater than 5, but many textbooks will also give a different figure here, okay? So that's a convention or the assumptions that we take. So if anything is above 5, that means multi-collinearity exists. That means there is a correlation. Now, how to deal with that correlation? That's a very big topic, not getting into it, but at its simplest, if we know that variable A and B both are very much have a lot of correlation among them, then it's better to drop one of that. But we cannot simply drop it. There are a lot of other considerations that has to happen, but I'm just saying that in a simplest term, we can take that approach of dropping it. The other approach is dimensionality reduction. We can use principal component analysis to do that. And the other concept is regularization. We can employ that regularization by which some of the irrelevant attributes, their coefficients are made to 0. I think it is lasso or reach, or one of these, I don't remember. They make the coefficients to 0 by penalizing the error. So that's another way of getting rid of irrelevant variables, right? There are many other ways to deal with multi-collinearity, but that's a very important thing to check when we do any modeling. Then what we are doing right now is the exploratory data analysis. Let me have a quick time check here. Okay. So there is something called pair plot in Seaborn library. Seaborn is another library, very fantastic library for doing the visualizations. As you can see here, the diagonal part, we are getting the distributions. Okay. And if you can see on the bottom right one, so this distribution looks more or less normal. And some interpretations, I'm telling you here, we can see some kind of correlation between this variable and this TV variable. And somewhere you will see it is completely abrupt. There is no correlation. So these are the things. Anyways, I'm not explaining what exactly is happening here across the variables. But the point is, once we put the once we draw this pair plot, we get to see the distribution of each and every variable and also the scatter plot between two attributes, right? So it also gives us some kind of good understanding about the data. Box plot is another way of looking at the distribution. This is the median, you can think, and this actually we could draw this horizontally also. This is the first quartile, this is the median, this is the second quartile, and this is the mean value, this is the max value. So we can see like whether the distribution is skewed or distribution is normal, that kind of thing. So if you see this line is exactly in the center, then the mean and median is same, right? So in that way, you can infer that it is perfectly normal, but we usually will not get everything perfectly normal. Some assumption is needed. And if you know from statistics that central limit theorem, so you will understand that sampling distribution of the mean finally gives us the normal distribution. But the box plot is very important to get some insights. If we have any outliers in the data, say, typically we spend around say, $1,000 in TV advertisement. And in one of the data point, you see there the TV expense or TV advertisement expense is say $20. That's kind of an anomaly in the data, right? That's kind of very unusual data that we at times come to see. Those kind of outliers, it can be on the higher side, it can be on the lower side, is very well detected in the box plot. And again, when we detect the high outliers, it's very important. If the outlier is there, then the model again will not give a good fit. And the model equation, which ultimately we would like to get insight out of, will also not be perfect. So we need to deal with that outlier. So dealing with that outlier again is a big topic. Not always we can simply delete that outlier. Maybe that is important, that has significance. I'll give you an example. One very typical use case in the IT world, what I have seen is if you give somebody to punch in the data, sometimes the manual mistakes are there. So those can be outliers. But let me give you an example about the outlier. It may be so that there is a separate group altogether, and though its representation is less, but it exists, and that business need to carefully investigate that before deciding on what treatment is needed for that outlier. And if that is the case, then we can add a additional variable, and just put a dummy value 1 into it, and rest all the records can be 0. And if you do that, you will see the model performance and the model accuracy becomes extremely it becomes much better. So as I said, we will not be dealing with the outlier treatment here. It's a big topic, but it's very important, and that's why I'm touching upon it. Continuing with exploratory data analysis, we talked about multi-collinearity. Sometimes we have to do the scaling of the data. Many a times we do this. There is a library in scikit-learn called standard scaler. So why we have to do the scaling? First of all, let us understand that. Suppose there are two independent variables, say TV and advertisement. Okay, it's not a good example, by the way. Let's take arbitrarily two variables, say, let's take age and income. Not in the context of marketing mix modeling, but let's take, we have age and income in the data set, and these two are independent variables. Age will range from what? Maybe from 20 to maybe 70, 80, and that's the range, right? 80 minus 20, 60. But if you see the income, somebody's income is, say, $4,000, and the other person's income, another person can have an income of, say, $15,000. Now, if you see the magnitude and the scale of these two attributes, one is like in 20, 50, and the other one is 15,000, 5,000. So it's a big difference, right? Now, when this kind of different scale exists in the X variables or the independent variables, the models again get biased. When I say biased, it's not that bias variance, but bias in the sense that the attribute which is having bigger value, in this case the income, will try to dominate the findings of that model, and which is not an accurate representation of the reality. So what we need to do, we need to bring them all the attributes into a common scale, and there are different ways of again doing it. Min max scaling. The other one is like take the value, deduct the mean, and divide that by standard deviation, and that's I think the standard scaler is doing here. But as I said, we need to, why we are doing, we have understood, and what is that it is doing, it is bringing that into a common scale. Say it is bringing it between 0 and 1, right? So when both the attributes are between 0 and 1, then they are comparable, right? And then we can build the model which will give us more realistic representation of the world. This variance inflation factor I have already
Mr. Samir, you are on mute. I think your line got muted.
Can you hear me? And now?
Yes.
Okay.
Yes, I can hear you.
Sorry
Please.
about that. Sorry about that.
No problem. Please continue.
So what I was talking here is, now we are getting into the model building, and always remember the model building is very simple. Definitely we need to know what is that model. We need to understand the concept of linear regression. We need to, if we are building logistic regression or decision tree or gradient boosting or any model, we definitely need to understand what the model is. And then only it will be helpful for us to decide which model is to be used when. No doubt about that. And that's why we learn all these things, right? So the important is paramount in terms of learning this model. But what I'm trying to point out here is, to implement the model in Python in itself, you see this may be a one-line code, or with more sophistication, we can add some 2-3 lines, and that's it. That's how we call the model. But once we learn the actual intricacies of that model, then we can tweak many parameters here. That's fine. So we just build the linear regression model, and this is our model. And then after building the model, we get some coefficients. So let me explain you what is this coefficients. So whoever knows Python, they will understand what this coefficient is. But let me talk in terms of business. And okay, so let's see this. After building that model, that model gives us 4 numeric values. And this we call it as coefficients or parameters. So it says that for banner, the coefficient is 1.22. For radio, it is 0.49. And for TV, it is 0.36. Okay. And this is how it gives. Okay. These 3 values that model gives us. Now, this is a very simple data set. So let's not argue or decide upon why it is 0.36 or why it is 0.49. Let's take this as a truth that this is what it is, right? And you can see there is another number 6678, which is not a coefficient of TV, radio, and banner, and this is called intercept. So if you recall our linear regression, not linear regression, the equation of a line from our school days, high school days, y is equal to mx plus c. That c was the intercept, right? So if you draw a slope, and if it is not originating from the origin, so there is an intercept in the y-axis. So that's the intercept, and here 6678 is that intercept. And these are the coefficients. Now the question is, what is the baseline sales? That is, if we do not spend any amount in any channel, the model tells us the baseline sales is, this is the sales. That is, without anything. So I was talking to you about that without any model, what is that business can get? I was talking there in terms of the average. Model is also throwing another figure, that is this intercept, right? So we need to understand the meaning of this intercept in this way, that without any other variable, this is the sales. Now let's understand what this actually means. So suppose if we spend $1 in TV, we will get 36 cents back as a contribution towards the sales. It's kind of weird, right? I mean, is it good that I'm spending $1 and I'm getting only 36 cents out of it? So it looks it's not doing well. The investment or towards this advertisement towards TV is not doing well. Well, don't construe this as the TV in general in marketing is not doing well. This is a very sample data. We are just taking this as an illustration perspective. So it can be for any channel. Here it is TV, and if it is 0.36, it is not good. On the contrary, if you see 1.22 is the coefficient for banner, that means if you spend $1 towards banners, it contributes to 1.22 times of that expenses towards the incremental sales, right? So look, banner looks good here from this equation, and these are the interpretations that we are making from this model. A very precise mathematical understanding how the channels are actually performing. Look, here is the very, very interesting thing that I have learned is we talk about predictive modeling, right? Prediction is definitely an important thing, because if we can predict the future, the business can then take good decisions, what they need to, how they need to allocate the resources, what they need to do, and all of that. But the statistical model is not just about prediction. It's the model equation in itself is of great significance, because it tells us the associations or the relationships of these independent variables very precisely in mathematical terms with the y variable. So a lot of insights we get out of this. Now think about this. That's good. That's very good insights that we are getting out of this model. Take this equation, get into a discussion with the business, with the VPs or senior VP or any other senior folks in the marketing or any other domain, right? By looking at this equation, they will not be so happy. They will say, show me the money, what it is. And we will start explaining that $1 spent here and all that. Some of them may be interested, but many may not have the time. It's not that they are not interested. They may not have the time to understand all of these and make sense out of it. So what's the better way? Because ultimately, when we are building the model, and that typically I have experienced this, that when I built a model and I feel that this is good for the business and I want to sell it, or I want to sell it so that it can be implemented, I need to show the business the value, right? My model can be extremely good, but if I can't communicate to the business what additional value it brings to the table, they may not be interested. So a very simple transformation of this information into business language. And as I said, it is very simple. So let me show you the next slide. Let's take this example. Okay, what is ROI, by the way? It's nothing but what is the channel's contribution to revenue, and what is channel's contribution to revenue? I said for TV, if I know the TV expenses multiplied by this, that is channel's contribution to the revenue. And if I divide that by the spending on the channel, that spending on the channel is the TV expenses, I get the ROI, right? What I'm getting out of my expenses, that is ROI for a particular channel. Let's take a row from our data set where we have 8,000, some odd 8,000 spending in TV, 4,000 in radio, banner 1992, and sales is 13,500 something, right? So what is TV's contribution to sales? So TV's contribution to sales is nothing but, what is the coefficient of TV? We know the coefficient of TV is 0.36. And from this row, we know the spending on TV is 8045. And this is my TV's contribution to the sales. Well, this is the TV's contribution to the sales, but how much I have spent on it, 8045. So you will see the ROI is not good, 0.36. And this is how you can represent and show to the business. Using any graphics, I'm just showing here the donut kind of representation. The TV is not doing good. Whereas, well, there is a typo here. This you need to read it as banner. So banner's contribution to sales, again, what is the coefficient? Banner coefficient is 1.22. 1.22 times how much was spent on advertisement. That gives me the TV's contribution to sales. And similarly, when we do the simple ROI calculation for this banner channel, we see that it is 1.22. It's much better than what TV is doing, right? So we can show it to the business that it is green. Just a caution here, when we represent this to the business, and business knows it much better, just because the TV channel is showing that it is the ROI is 0.36, it is not doing good, it does not mean that next period will take all the money out of TV and put that into the banner. That's not the intention. It's about knowing which is doing relatively better, because there are a lot of things that our model may not be able to capture, and TV probably is also contributing, though not significantly. In technical terms, there is another thing called interaction effect, right? This particular attribute looks like is contributing in X way, but when we take the interaction effect of two other attributes with TV and some other attribute, that may or may not again have a significant impact towards the variable, right? So there are a lot of things, but this is in general, we can say TV is not doing good, right? But we can bet on this banner based on this model, and that's how we can tell the business. And business people probably, because of their experience, just because they are into that business for such a long time, and also they have the domain and the industry experience, they probably will be able to tell you, yes, look, the TV is not doing good, but then maybe TV is also important because of this and that. And that's how we learn the domain knowledge and get the industry experience, right? Just a caution here in that front. Well, we built the model, we interpreted the model mathematically, we communicated to business which channel is doing good, which channel is not doing good. Accordingly, the business now can decide how to optimize the revenue, because ultimately revenue is influenced by TV, radio, and banners. And we know how TV, radio, and banner is influencing sales. So obviously, they now know what is happening to sales, and they can take a business decision as to what is to be done for the next period. So this is data-driven decision making, right? We are aiding the business to make good decisions based on the statistical or machine learning models. But this is a very simple model, right? These three attributes, and the people who are here in the audience, is a simple linear regression, three attributes, and we just ran the linear regression model and we got the coefficients. But again, I would like to say that though it is a very simple model, but it can convey a very, very significant insight to the business. But this model is not perfect. It is a very base model, very simple model. So what are the drawbacks here in this model? Okay. So we are in the month of June now, right? So suppose I'm spending 25,000 rupees towards say newspaper advertisement, and the assumption in this model is this will contribute to the sales of this particular month. Say in the first 1 or 2 days I have spent that amount on this particular channel, and expecting this month itself the sales will be impacted. Sales not impacted in the positive way. The sales will grow because of this ad spend. But actually, that is partially true, because think about it. When you see an ad, either in Facebook or in newspaper, first time you see it may not catch your attention. But when you see the ad maybe multiple times, you pay attention to it, and maybe then you start considering about that particular product. Then you do your research, you try to figure out what are the competitor products, you check the price, features, you do all of that research, right? Whether you go and visit the store or you do the online research. Nowadays we do a lot of online research, we read the reviews and all that. So you saw the ad first time this month, and then you are doing all of this consideration, research and all that, comparisons, and maybe next month you decide to purchase. You may not purchase, but you may purchase next month. So your purchase next month is actually influenced. So you are purchasing that in July. So your purchase in July is actually influenced by that spend in the month of June. In a general term, the sales of a particular period may be getting influenced by that spend of the previous period, right? So this model did not consider that thing. And this is a very well-known concept in marketing space. It's called ad stock. You can Google this. There are a lot of information out there in the web. Very interesting topic. You can learn about it. And so at stock, this effect that I was talking here is the lag effect or the carryover effect. And I'll show you one diagram to tell it more. There are a lot of other complexities here, not complexities, the different variations of this lag and carryover effect. We'll talk about that. Then there is very interesting thing that we learned that what was that banner 1.22 times banner. Well, put some money into the put additional money into the banner, the sales will grow. But we are sitting, the company is sitting on a lot of cash, right? Loads of cash the company has, and then company thinks that we will increase the marketing expenses to a huge amount. And since banner is doing good, the coefficient is 1.22. Let's put loads of money into the banner ads. Expectation is that sales will grow proportionately, right? But does it happen? I mean, there is a saturation effect, right? Beyond the point, this ad will not work. Yes, initially the advertisement will generate sales, incremental sales will increase, but beyond the point, any additional money spent will not generate any incremental or marginal sales. It is again the same concept of that law of diminishing return, if you know that. So it's basically to understand in a simplest way the saturation effect, right? Our model did not consider about this saturation effect. Okay, so these are the two things that we did not consider in our model. It's not actually a drawback. It's just that our model was a simple model, and now if we have to incorporate these things into our model will become a better model. And let's talk a little bit more about this two aspects of at stock. Okay. So you look at this, and let's look at this formula. At stock rate, let's take this as a percentage, 50%, 60%, any percentage. Okay. So what we are saying is XT, that is the spend in this month in a particular channel is important, but definitely it will contribute to sales. But the previous period's spend, or that stock figure, that spend, let's take this as a spend, previous figure, because T minus 1, a percentage of that, not fully, maybe 30% of it, maybe 40% of it, maybe 70% of it is also contributing along with this month's figure to calculate this month's at stock value. Now, there are a lot of things that I've talked about. So in terms of this diagram, you can think of this month's sales is actually getting influenced by previous month's spending. Now the question is it only dependent on just one previous period, or is it dependent on previous 2 periods or 3 periods? So these are some of the things that's the fun of model building. We need to try out different things, and I'm talking here, there are a lot of sophisticated tools and techniques are there today, and I will mention about that. But typically in model building, it's all about trying out things, right? Trying out things, and people who are from data science and machine learning, you guys know the hyperparameter tuning, right? Grid search CV and all that. So it's a kind of that hyperparameter tuning. What's our hyperparameter here? At stock rate, what is that percentage is one such hyperparameter, whether it will be 0.7%, 0.6%, 0.3%. Well, if you see the marketing literature, a lot of work has already been done, and for every industry, some benchmark is already exist. So you can always get it from the literature, like for this particular industry, what is that stock rate that is being taken. But again, there is a difference of opinion, and you can always try out the different variations of it and see which gives you the better result. Similarly, like in terms of going back in time, how many periods, that's also a kind of hyperparameter you can think of, whether it is 80 minus 1 plus another figure, which is 80 minus 2, kind of this thing is again something that we need to try it out. And as I mentioned that I will tell you something very sophisticated models which are available now, which can do all of this, which can simplify all of this task, automate it, and give it to us the results in a very nice way. To this particular equation, it's a simple Python code. I've taken it from this particular site, and it's very simple. What it is doing is it's just taking the expenses, the current expenses, multiplying that, adding that with the previous period's expenses, exactly the same previous period's expenses, why it is I minus 1, and then multiplying that by add stock rate and putting it here and putting that into a list. And finally, we get the data. Okay, so this is nothing but if you understand this equation, this code will make a lot of sense. And again, this is just one way of writing. There are many ways of representing the same thing in Python, and again in many different languages. Just for the sake of completeness, I just put this Python code here, which implements this particular equation. Okay. Now, yeah. So I was talking. I mentioned to you, right? How many future periods will continue to have the effect of previous period? I'm putting this in a different way. And what percentage of ad spend effect will carry over to future period, right? So to get these questions, as I said, we have to try out the models iteratively and find out the best parameters which we can use in the model. Definitely, it is a time-consuming process, but it is worth. Facebook Robin has a very sophisticated solution, and I have given some links here. You can check it out. Robin is an automated marketing mix modeling open source code, and this link is there: Facebook experimental.github.io.robin, and there are some very excellent articles that I have gone through. It's from Cassandra site. These two articles also talks about the Facebook Robin. We are not discussing the Facebook Robin here, but just know that it is an automated marketing mix modeling, and many of these questions that we have in mind is handled in a very nice automatic way. So if you are interested, you can definitely check these things out. And then comes the saturation. And I explained you what is the saturation, right? So let's take forget about this curve. Okay, let's say this curve is not there, and let's take the x-axis is my advertisement expense. And if I keep on increasing the advertisement expenses, then I would expect a line straight like this going towards the infinity. That means the more I add, more I spend on advertisement, let this axis be sales. Okay. So when I keep on increasing the advertisement expense, the sales will keep on growing. That is the assumption. But we know that is not true. There is a saturation effect in place. So how do we handle it? How do we handle it? So here you can see that this particular axis, we are limiting it to between this figure, 0 to 1, right? So beyond a point, when we start increasing the expense, we see that y-axis is increasing. That's fine up to this. And here you can see that we are hitting the saturation, right? So beyond this point, if I increase the x, which is my advertisement expense, we are capping the y variable to 1. And how do we do that? There are many. So first of all, you need to understand what we are doing. We are capping it between 0 to 1, the y variable, right? And that way we are taking care of the saturation effect. There are many ways of doing it. One of them is using the exponential function, and I mentioned it here. That is exponential of this minus 0.7 into x. And if we do this, apply this transformation, we will see it comes between 0 and 1. There are many ways of doing it. Okay, exponential function is just one way of doing. You can check this thing in the marketing literature, in the internet. There are a lot of articles which talks about different transformation which can give us this saturation effect. We can implement this saturation effect. And here again, a simple, very simple Python code to achieve this. And what we are achieving ultimately, this is the 1 minus exponential of minus 0.7x. We are just implementing that in the Python snippet. So the important thing here is that these three graphs, right? What this thing tells us, say we apply this transformation to each of the channel. So what it tells us, one is, yes, definitely our model becomes better with this saturation effect. We can plug this knowledge into our model, and the model becomes more sophisticated. But you see these diagrams by just doing this transformation. You can see here, banners, you can see this is the one, right? Banner has already reached the saturation. Banner has already reached the saturation. So contrary to what we were thinking, that 1.22 is a very good coefficient and we will keep spending money on banners and it will give us a marginal and incremental revenue, that may not be the case. We may try it out, but this particular saturation diagram is telling that we have already reached a saturation. More we spend here, we may not be getting proportionate amount of incremental sales. Whereas if you can see here for radio, there is still some room. There is still some room. We can still spend a little bit more. Now, whether we spend a little bit more here depends on that coefficient. Well, I did not touch upon a few other things in the model because this session is not about the model, because for each of the attribute, you will get a p-value, right? So in general, if the p-value is less than 0.05, we consider that particular significant, that attributed as significant. So say that radio is a significant attribute, and say the coefficient is also significant or not significant. It is a good coefficient. We are thinking that it can contribute to the sales, and from the saturation graph, we see that there is some room. Then maybe business can then decide whether to put some more money into radio. Whereas we can see the TV, where there is big gap here, right? So these are some of the informations that additional informations that is related to this particular model. When these are incorporated, our model becomes more sophisticated, right? So yeah, that's all I have for today. And my mantra, which I tell myself and I tell everyone in today's world, we need to learn. We have specifically people like me who have been in the industry for such a long time. We have learned many things, but many of the things have also become a baggage. And we need to unlearn a lot of things and then relearn. And it is a continuous journey. So thank you again, everyone, for spending the time here, patiently listening to me in this Saturday evening. Thank you, everyone.
Thank you, Mr. Samir, for the very informative session. I'm sure our audience have gained a lot from this session, and wishing you have more such sessions in future from you. Thank you. Thank you, Samir.
Thank you very much, Sharath.